So in previous session we observed parallel circuits and series circuits. Now the thing is with respect to AC circuits whose excitation element is an AC source. So that we can observe over here. This is what the signal generated by the signal generator. Unlike DC source, which is a constant, AC source has variable current and voltage at regular intervals of time. Generally, high power applications, these AC circuits are used. And this is what the simple circuit, which consists of voltage source, and this is what the representation of alternate current passing through the resistor. And the ratio of current and voltage depends upon the phase and the frequency of the supply. And the applied voltage will change constantly with time. So Ohm's law can be used to calculate current passing through the resistor at any instant of time. So that is given by I is equal to V by R. And when the switch is closed, current passes through the resistor and gives the equation I is equal to Im cos omega t plus phi, and voltage is given by V is equal to I into R. See, this is what the circuit with respect to AC signal along with the inductance. So here a coil of thin wire wrapped on cylindrical core, which is known as inductor, and the core can be an air core or iron core. As alternating current flows through the inductor, the magnetic field also changes, and this change in magnetic field results in induced voltage across the inductor. So as per Lenz's law, the induced voltage is such that it opposes the flow of current through it. And during the first half cycle of the source voltage, the inductor stores energy in the form of magnetic field, and in next half it releases the energy. And this is what the expression of induced electromotive force, where L is the self inductance. And this circuit represents AC circuit along with, that means AC signal along with the capacitor. So here the constant DC supply, the capacitor plates charge up to the applied voltage and stores charge temporarily, and then it starts discharging. Once a capacitor fully charged, it blocks the flow of current as the plates get saturated. Let us see what is a short circuit and open circuit. So short circuit, it is a low or negligible resistance connection between two conductors in an electric circuit that are termed as short circuit, and this results in the production of heat and sparks, or even the flames or smokes. And this causes majorly this leads to, or this happens because of loose connections or faulty insulation or abrupt chewing up of wires by pests or old appliances. So one of the best commonly used techniques to prevent damages using short circuit is using a fuse. Using a fuse, or the other name of fuse, it is a circuit breaker. Next is open circuit, where an open circuit is caused due to an interruption in the electrical circuit. When any element in a circuit is left unconnected, an open circuit is created, while Voltage across an open circuit has some finite value, that is current, obviously it will be 0. So how to protect the circuit? With the deliberate installation of a weak link within the electrical circuit, which is known as circuit protection. And the major purpose behind this installation is to prevent of damage due to short circuit and excess amount of temperature. Other damages can be overcome, and this circuit protection device can be fuse, a circuit breaker, a thyristor, or a switch. So with the help of circuit protection or circuit protection devices like fuse, circuit breaker, thyristor, or switch, we can overcome the short circuit damages.